Hello. Before beginning application development on a new board, you want to make sure the hardware is working properly. This video provides an introduction to board diagnostics delivered with the Processor SDK RTOS and demonstrate how to build and run the test on AMIC 110 Industrial Communication Engine board from the SPI Flash. The purpose of this video is to introduce the TI Processor SDK RTOS diagnostic package, what devices are supported, what board and peripherals are supported, how to build, run, and validate the test. Some useful references are provided. This video is part of the How to Run Processor SDK RTOS board diagnostic series. We will focus on using SPI Flash to run the diagnostics on AMIC 110 ICE board. The diagnostic package is a set of bare metal tests to run on a board to track data path continuity on peripherals. The diagnostics support multiple SATERA devices, K2G and OMAP L13. The peripherals supported are quite device and board dependent. There may be different EVM boards for each device, and each board may have different peripherals. A few are just listed here as examples. How to build the diagnostics? It is Makefile based. How to run it? For those EVMs supporting MMCSD, it's loaded through the SD card. This applies to most of the EVM board. For ICE AMIC 1110, it does not have MMCSD slots. The diagnostic test is loaded through SPI. For the OMAP L137 EVM, it does not support executing from a boot device. Diagnostic test binary need to be executed from CCS. In general, CCS can also be used for debugging purpose. This is the primary link for board diagnostics. Let's take a look at the diagnostic file structure in Processor SDK RTOS. Under Diag, there are many peripherals. Then under Build, there's what EVM are supported. SRC is the source code folder. Common folder has a disassembly code to enter the test application. It also has some common configurations and the linker command file. Framework loader folder is to load the framework. Framework folder, this is to pass the test cases, run and print test status. This folder file also do the board setup. Before we proceed to the demonstration, let's review the steps in the board diagnostics process using SPI. First, we will set up the build environment. Next, we will compile the diagnostic applications. Once the applications are compiled, we will write the SPI Flash with pre-built images. We will then boot the board with the SPI Flash and run. Finally, we will verify the diagnostic output on the console. Before compiling the diagnostic applications, setting up the build environment, the diagnostic application uses the same environment variable as the board library build. Refer to Build SDK in the Processor SDK RTOS developer guide for more information. The libraries shown here are needed. They should come pre-built with any fresh installation of the Processor SDK. Set up your environment using the PDK setup env script. We will build the diagnostic applications for AMIC 110 ICE board. Next, we will compile the diagnostic applications. Change the build directory. Then use the make command to build in Linux environment or gmake in Windows. Change the build directory, then use the make command to build. From the output folder, you will see app. This is the framework loader. You will also see framework and several test applications. You need the pre-built bootloader and flash writer as shown in above locations. First, start CCS and launch target configuration file for AMIC 110 ICE board. Then connect the target, load and run the SPI flash writer binary. From the CCS console, choose option 1 to initiate image flashing. Enter the file name for SPI bootloader along with full path, and enter the offset as 0. Wait until flashing completes successfully. This takes a few minutes. The video shows this process. Similarly, rerun the SPI flash writer binary and the program diagnostic framework loader at offset 20,000 hex. Finally, rerun the SPI flash writer binary and the program diagnostic framework at offset 40,000 hex. Note, this framework has all the test applications embedded, so you don't need to flash each test application one by one. Here is how the diagnostic works. The secondary bootloader loads the framework loader. Then the framework loader loads the framework. In the framework, you can select each test to run and see the result. Here is an example running board diagnostics on AMIC 110 ICE board. When the board boots up from SPI flash, you will see the output from the UART console. The framework lets you run a test application or show the test result. Just select a test number to run, and you will see the outcome. When the test finished, you can select the next test. For example, test number 2 is for EPROM. The EPROM contains the board-specific information and allows the processor to automatically detect what board is connected and the version of that board. The test prints out this information stored in the EPROM. Finally, we will verify the diagnostic output on the console. You can also use status command to query the test result. For a new EVM, all the tests are expected to pass. This concludes the demonstration of diagnostics using the SPI flash method. For more information, please refer to the links shown. Thank you for taking time to watch this video. If you have any questions, please post them on the Texas Instruments E2E forum at e2e.ti.com.